1 into 3 plus 2 into 3 square, 3 cube, n into 3 raised to n. Now, let's begin from the basis step. N is equal to 1. So, on left hand side, we have to take our first term is 1 into 3, or we can say 3. On right hand side, we have to replace n by 1. So here we'll get 2 minus 1, 3 raised to 1 plus 1 plus 3 divided by 4. It will give us 3 square, or we can say 9 plus 3 by 4. 3. So here your left hand side is equal to right hand side. So your P of n is P of 1 is true. Now let's try to solve induction step. First of all, we have to assume P of k is, and to form P of k, we have to replace your n by k. 1 into 3 plus 2 into 3 square up to dot 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 k into 3 raised to k is equal to 2k minus 1, 3 raised to k plus 1 plus 3 whole divided by 4. Let's call it equation number 1. Now, we have to prove P of k plus 1, and P of k plus 1 can be formed by replacing n by k plus 1. 1 to k terms will be as it is plus k plus 1 term, or we can say k plus 1 into 3 raised to k plus 1 is equal to 2 of k plus 1 minus 1, 3 raised to k plus 1 plus 1 plus 3 divided by 4, or we can say 2k plus 1, 3 raised to k plus 2 plus 3 divided by 4. Now, let's try to prove this thing. Let's begin from the left hand side. Now, we already know the summation of first to kth term, which is given in equation number 1. It will be 2k minus 1, 3 raised to k plus 1 plus 3 whole divided by 4, and your k plus 1 into 3 raised to k plus 1 will be as it is. Now let's try to simplify. Let's take LCM of 4. So this 2k minus 1, 3 raised to k plus 1 plus 3 will be as it is. We have to multiply 4 with the another term. So we'll get 4k plus 4 into 3 raised to k plus 1 will be as it is, whole divided by 4. Now we can take 3 raised to k plus 1 common from these two terms. So we'll get 3 raised to k plus 1, and remaining terms are 2k minus 1 plus 4k plus 4. This plus 3 will be as it is, divided by 4. In further simplification, 2k plus 4k will be minus 1 plus 4 will be plus 3. Or we can say we can take 3 common from this bracket. So we'll get 2k plus 1 plus 3 whole divided by 4 will be as it is. So if we multiply 3 with the 3 raised to k plus 1, we will get 3 raised to k plus 2, 2k plus 1 plus 3 divided by 4, which is required right hand side. Hence P of k plus 1 is true, therefore P of 1 is true, P of k is true, P of k plus 1 is true. P of n is true by principle of mathematical induction. Ta-da! P of n, which is 1 into 2, 2 into 3, 3 into 4, up to n into n plus 1 is equal to n into n plus 1, n plus 2 by 3. In basis step, you have to check P of 1, and for that we have to put n is equal to 1. So on left hand side, we will select the first term, which is 1 into 2 will give us 2, and on the right hand side, we have to replace n by 1. So we get 1 into 1 plus 1, or we can say 2 into 1 plus 2 will give us 3 whole divided by 3. 3 will cancel out, we will get 2. So your left hand side is equal to right hand side. So your P of 1 is true. For induction step, we have to assume P of k is true. And to get P of k, we have to replace our n by k. 1 into 2 plus 2 into 3 plus 3 into 4 up to dot 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 k into k plus 1 is equal to k into k plus 1 into k plus 2 whole divided by 3. Let's call it equation number 1. We have to prove that p of k plus 1, and for that we have to replace our n by k plus 1. So on the left hand side up to kth term it will be same, plus k plus 1 term will be k plus 1 k plus 2 is equal to k plus 1 into k plus 2 into k plus 3 whole divided by 3. So let's try to prove this thing. Let's begin from the left hand side. Now we already know the summation of first k term from equation number 1. We can say its summation is k into k plus 1 into k plus 2 by 3, and k plus 1 and k plus 2 will be as it is. To simplify this, we can take k plus 1 and k plus 2 common. So remaining terms are k by 3 plus 1. In further simplification, k plus 1 and k plus 2 will be as it is. If we take the LCM of 3, we will get k plus 3 by 3, which is your required right hand side. So p of k plus 1 is also true. So using PMI, we can say our p of n is true for all n belongs to n. Ta-da! Your p of n is 1 into 3 plus 3 into 5 plus 5 into 7 up to 2n minus 1 into 2n plus 1 is equal to n into 4n square plus 6n minus 1 by 3. And to prove this thing, let's begin with the basic step. We have to find p of 1, and for that we have to put n is equal to 1. So on left hand side, we have 1 into 3. 1 into 3 will be 3. Now on right hand side, 1 into 4 plus 6 minus 1 divided by 3. Or we can say 6 plus 4 minus 1, 9 by 3 will be 3. So your left hand side is equal to right hand side. Therefore, p of 1 is true. Induction step, we have to assume p of k is also true. And to form p of k, we have to put n is equal to k. 1 into 3 plus 3 into 5 dot 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 2k minus 1 into 2k plus 1 is equal to k into 4k square plus 6k minus 1 upon 3. This is your equation number 1. Now, to prove p of k plus 1, let's form p of k plus 1 by replacing n by k plus 1. First k terms will be same, plus 2 times k plus 1 minus 1 into 2 times k plus 1 plus 1 is equal to k plus 1 to 4 times k plus 1 the whole square plus 6 times k plus 1 whole divided by 3. Or let's simplify as 1 into 3 into 3 into 5 up to dot 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 plus 2k plus 1 into 2k plus 3 is equal to k plus 1 4 times k square plus 2k plus 1 plus 6k plus 6 minus 1 whole divided by 3. Or we can say k plus 1 4k square plus 8k plus 6k 14k plus 4 plus 6 minus 1 9 whole divided by 3. So let's begin from the left hand side. We know the summation of 1 to kth term from equation number 1. We can say it is k into 4k square plus 6k minus 1 upon 3 plus k plus 1 and 2k plus 3 will be as it is. Now let's simplify. K 4k square will be 4k cube plus 6k square minus k plus 3 into 2k, 2k is a 4k square, 2k, 3 is a 6k, 1 into 2k will be 2k, and 1 into 3 will be 3, whole divided by 3. 4k cube plus 6k square minus k will be as it is. This 6k plus 2k will be 8k. Now multiply 3 within the bracket. 3 4k is a 12k square. 3 8k is a 24k plus 3 3 is a 9, whole divided by 3. In further simplification, we can say 4k cube is as it is. 6k square plus 12k square will be 18k square. 24k and minus k will be 23k plus 9 will be as it is, whole divided by 3. હું સાઈડમાં ફેક્ટર્સ કરીને બતાવું છું. 4k cube plus 18k square plus 23k plus 9. તમે લોકો શું કરતા હતા? k ની અલગ અલગ વેલ્યુઝ પ્લેસ કરીને ચેક કરતા હતા. k equal to 1 પ્લેસ કરો, so you'll get 4 plus 18 plus 23 plus 9, which will be not equal to 0. Next check करता था, k equal to -1 place करें, so it will be -4 plus 18 minus 23 plus 9. आ 0 થાય છે, check કરો તો. Yes, 0 થાય છે. So that means k plus 1 is one factor. અને આના factors કરવા માટે તમે લોકો long division method use કરતા હતા. Coefficient of k cube 4, coefficient of k square 18, coefficient of k 23 and constant term 9. -1 place કરવાથી આવ્યું તો -1 place કરી નાખો, અને અહીંયા compulsory 0 જ place કરતા હતા. Now add 4 plus 0 will be 4, 4 into -1 will be -4. Same steps ને follow કરો ફરીથી. તો 18 minus 4 will be 14, 14 minus 1 will be -14, 23 minus 14 will be 9 and -9. This is your coefficient of x square. This is the coefficient of x and this is the constant. So you will get 4x square plus 14x plus 9 into 1 and original factor, which is k plus 1. So instead of 4k cube, 18k square and a 23k plus 9 will be k plus 1, 4k square plus 14k plus 9, whole divided by 3, which is your right hand side. Hence p of k plus 1 is true, therefore p of 1 is true, p of k is true, p of k plus 1 is true. P of n is true by principle of mathematical induction. Ta-da! P of n is 1 into 2, 2 into 2 square, 3 into 2 cube, up to n into 2 raised to n is equal to n minus 1, 2 raised to n plus 1 plus. Let's begin with the basic step. N is equal to 1. Left hand side so also 1 into 2 will give us 2. Okay. Now what about right hand side? So your first term will be 0. So it will give us 2. So left hand side is right hand side. Assume that p of k and replace by k. 1 into 2 plus 2 into 2 square up to dot 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 k into 2 raised to k is equal to k minus 1 into 2 raised to k plus 1 plus 2. This is your equation number 1. Now let's try to prove p of k plus 1. N is equal to k plus 1. N is equal to the same plus k plus 1 into 2 raised to k plus 1 is equal to k plus 1 minus 1 2 raised to k plus 1 plus 1 plus 2. Or we can say k into 2 raised to k plus 1 plus 2. Let's begin from the left hand side. 1 to k નું સમેશન અહીં ક્યાંય દેખાય છે સ્ક્રીન પર? એના પકડીને આપણે plus will be as it is. Okay. Now we don't have to worry about this plus 2. Just move it outside. So we can take 2 raised to k plus 1 common. So remaining terms are k minus 1 plus k plus 1. This plus 2 will be as it is. 2 raised to k plus 1 is, and plus 2 will be as it is. Minus 1 plus 1 will be cancelled out. K plus k will be 2k. Or we can say 1 power of 2 raised to k plus 1 will increase. So k into 2 raised to k plus 1 plus 2. Hence, p of k plus 1 is true, and using PMI, we can say p of n is also true. Ta-da! P of n is 1 by 2 plus 1 by 4 plus 1 by 8 up to 1 upon 2 raised to n is equal to 1 minus 1 upon 2 raised to n. चलो start करो. Left hand side, પહેલો જે term હતો એ 1 by 2. Right hand side માં 1 minus half will be half. So your left hand side is equal to right hand side. So P of 1 is 2. N is replaced by 1 minus 1 upon 2 raised to k. Equation number 1. Now let's try to prove P of k plus 1. And to form it, you have to replace n by k plus 1 is equal to L. આપણે prove કરવાનું છે. Let's begin from the left hand side. We will use equation number 1, in which we already have the summation of first to kth term. So let's replace the whole bracket by 1 minus 2 raised to k, and 1 upon 2 raised to k plus 1 will be as it is. This 2 raised to k can be replaced 2 raised to k into 2 raised to 1. So let's take minus 1 upon 2 raised to k common. So in first term, 1 will be remaining, minus in second term, 1 by 2 will remain. So 1 minus 1 upon 2 raised to k will be as it is. 1 minus half will be half. So here we'll get 2 raised to k plus 1, which is your required right hand side. Hence, P of k plus 1 is true, and using PMI, we can say P of n is also true. Ta-da!